Last class we started with the position analysis. Okay, so we defined our coordinate system, and then we talked about something about the displacement, the translation, rotation, and the complex motion. Because the links, whatever we will have, they will either go for translation or rotation or a combination of both. Okay, so those things we dealt with. Okay, I have defined the things, and then I started talking about the loop closure equation. I mean, in the start, you may feel that why I am going through all these, okay, this loop closure equation. But the fact is, once you are able to write this loop closure equation, we can basically use the analytical techniques, I mean the algebraic solution of the equations. You can go for the graphical solution as well. As I have told you earlier, अच्छा मैं उनसे भी पूछ लूँ, सब दिख रहा है ना? I'm sorry. Just once. कुणाल गुप्ता यहाँ तो नहीं आया ना? ललित शर्मा, निखिल?
Yes, sir.
Yes, sir.
कुणाल गुप्ता?
Yes, sir.
कुणाल?
Yes, sir. Yes, sir. Yes, sir.
आवाज मेरे पास नहीं आ रही क्या? अच्छा चलो आशुतोष तुम लॉगिन करके चेक कर लो, सब आ रहा है ना ठीक? वो सब सो रहे हैं अभी. Okay, so the loop closure equation is the basis of our entire analysis. One more thing I wish to tell you, that among all the analysis, whatever we are going to perform, position, velocity, and acceleration. Of course, the position analysis we will not, deal in details, because that is the synthesis part. But typically, the position analysis is the complex one out of these three: position, velocity, and acceleration. For position analysis, if you are going mathematically, you have to develop nonlinear equations, and possibly still you do not know how to solve those nonlinear equations. You will go through Newton-Raphson, etc. in this particular semester. Okay, so the position analysis, just I will tell you how to construct our 4-bar mechanism or slider crank mechanism. I mean, you can, with the help of, because we will be dealing only the graphical part. Okay, so in graph, you know that if the data is properly given, I mean the length of all the links is known to you, one angle is known to you, so you can easily draw the the kinematic diagram, you can say, for the mechanism. And once that diagram is known, then we can move ahead for the velocity, etc. Now the question is that how the velocity of each and every link is connected, because there is one crank, one coupler, and then the rocker, the output link. So how the velocity components are related with each other. So that we are getting from the loop closure equation. Loop closure equations are basically what? The position vectors. मैंने last week में आपको I started with the vectors, some concept, notation of the vectors. This I will be following in the loop closure also, the same notation. So the loop, in the loop closure equation, what we are writing? We are writing the position vectors. Okay. So if you have written the position vector, you differentiate it, what you will get? The velocity vector. You differentiate it again, what you will get? Acceleration. Okay. So overall, the thing is, we have a proper, clear idea about the velocities, the acceleration, the relations. So once the relationship is known, we can go for the graphical method. And there I told you there can be 4 possible cases. Although I have taken only 2 vectors, 3 vectors, C is equal to A plus B, if you see. Okay, but in any case, whatever number of vectors are involved in that equation, the maximum number of unknowns will be how much? 2. If the number of unknowns are more than 2, it means you will be looking something else. You have to find out some other relation also. Okay, because you cannot solve for more than 2 unknowns in these equations. So I have shown you the notation that vector C, it will have 2 components, the magnitude and the direction. You all know. Direction means unit vector, and magnitude. Okay. Similarly, vector A, vector B. So each of them will have something like this. So when you are writing the equation, you simply tick mark. If magnitude is known, then the first one will be tick mark. If direction is known, then second one will be tick mark. Like if you see case number 2, this case number 2, if you see here, okay, what we have, C is equal to A plus B. So on C, I have put two tick marks. It means what? That magnitude and direction both are known. For vector A, the first one is question mark, means magnitude is not known to us. Okay. And for B, second one is question mark, means direction is not known to you. Okay. So these are 4 possibilities. And actually you have to learn. I will give you this assignment. Okay. If you are not able to draw, I will tell you the last one. Actually, that is a little bit possibly complex. आपसे भी बोलूंगा अभी draw करिए उसको. That may be the case that you cannot draw that one. 1, 2, and 3. Those 3 cases you can easily draw because in at least one magnitude or direction something is known. Okay. Like let me take the case 1. केस 1 तो बता दिया था आपको or not? I mean 2 vectors are known to you, third vector, that is the resultant you have to find out. So ये आप लोग regular करते हैं. Okay, so I'm not talking about that one. Now the second one, you see the vector C is known to you. Okay, let me say that vector C is something like this one. This is vector C. For vector A, direction is known to us. Direction means I will say that for vector A, this is the direction, vertical, upward. Okay, that direction is known to you. And for B, what is known? Magnitude. Okay, so for B, magnitude is known, and for A, direction is known. Okay, so what you will be doing with respect to C, first you draw the direction, I mean either at the head or at the tail. And from second point, what you have to do? You have to cut the arcs because the dimension is known to you. So you choose this arrowhead as center. And then what you do? You cut the arc, something like this one. Okay. Now you join it. So there are 2 possibilities actually. Okay, the one is that A is going downward, another is A is going upward, but the upward direction is known to you. So simply vector A will go upward, and then what will be the direction of vector B? Vector B will come because it has to close. C is equal to A plus B. C is the resultant of A and B. So vector B will be coming downward. Okay, so you can draw this particular vector. Similarly, the third one you can draw, you will be dealing with this one. आप लोग किए होंगे. Otherwise, later on, once we start the velocity analysis, whatever problem we find out, we'll tackle with that. The last one I will show you, because the magnitudes are known to you. For vector A and vector B both, the magnitudes are known to you, direction is not known to you. Okay, so this one is little bit possibly new. So first of all, what I will do, I will draw vector C on scale. This is the graphical part, you remember. When you are going for the graphical analysis, this is the way you have to perform the graphical part. So vector C I will draw. Okay. Now there are 2 vectors, A and B. Magnitude is known to you. And we have got 2 points. One is what? The tail of vector C. Another is what? The head of the vector C. Okay, so from this position, I mean you choose the tail of the C as center and then draw one arc, something like this one. Okay, and this is what? This is the magnitude of vector A. This is magnitude of vector A. So now we have drawn vector A, I mean magnitude. B is remaining. So for B, which point I will choose? The head position. You cannot draw from the same position. For B, I will choose this head position. So if you are choosing this head position and then you draw again some arc. Okay. So that arc definitely it will be little bit, I mean, depending on the position, this will be what? For B. And I will show you the direction. This second one is for vector B. Okay. So now what you have to do, you are getting two intersection points. The one is here, let me say point 1, another is here, point 2. Okay. What you have to remember, that A and B will be head to tail combination because they are addition and C is the resultant. So I will start now from point C. You join the lines first, this line and this line. And you know that since C is the resultant vector, here you will be getting one arrowhead. Resultant, hai na? So here you will be getting one arrowhead. So if one arrowhead is here, another will be over here. Am I correct? Okay. Now let us see which one is A and which one is B. A vector we have drawn from this position. मैं इसको point लिख दूं कुछ? Point 1, 2, 3 and 4. A vector we have drawn from point 3. So this one is what? A. And B vector we have drawn from point 4. So this one will be what? Our B vector. Okay. So this was something new. Possibly in 12th, maybe you have not gone through this one. Other two cases you can easily deal with. Otherwise, during tutorials or classes, when we are dealing with the velocity analysis, we will deal with. Okay. Now let us come to the loop closure because we already have lost too much time. Okay. So just I will start with this loop closure. I may require another class, but anyway, no issue. Loop closure equations. Okay. So if you see here, I have shown a particular mechanism. This is the clamping device. Okay. So actually, if you are moving it upward, what will happen? It will release the clamp. This clamp will also move upward. Okay. And if you are moving it downward, this clamp will go downward, and whatever object you have here, it will clamp that particular object. Okay. So this is a clamping device we are using. The links are already shown here. Okay. Link number 1, that is the base part. Link number 2 is another one. Link number 3 is here where you are applying the force. This one is link number 3. And the link number 4 is what? The clamping part. Okay. Now you remember one thing, that till now I have given you only the simple line diagrams kind of thing. Okay. But when you are solving the problems, you will be getting any mechanism. Okay. The mechanism will be shown to you. You have to identify the links. Okay. What kind of links are there? You develop the diagram. Then you go for the mobility. अभी तक तो आपको सिंपल हम लोग दे देते हैं. This is the diagram and you find out the mobility. So that is something you have to work upon. Although I'm working on that tutorial, and hopefully by end of this week, that tutorial will be ready for you all. Okay. So that is the real test, whether you understood the topic or not. Okay. But here anyway, so if you see, actually this is 4-bar mechanism kind of thing. Okay. 1, 2, 3 and 4. Loop closure equation is what? That we are creating a vector addition kind of thing. We are starting from one point and again we will be forming a loop and we will be coming to the same point. Okay. So if you are able to do that, then you know that the total sum of that vector must be equal to 0, because the total distance traveled is fine, but total displacement is 0. You started from A and you came back to point A. So that is the loop closure equations. There are different ways you can write down. So I will start with only one. Okay. And then you can, work the way you want. Okay. Let me say, I will take another point. I will not start with point A. Okay. Point A, B, C, D. Is it visible to you? This is point A. Here we have got point B. Here we have got point C. And here we have got point D. Okay. So if you see, we have got 4 nodes or the joints. 4 joints. Okay. A, B, C, and D. and we will be moving from one joint to next, and then to next. Okay, and I will take the origin, let me say, as A. So if that is the thing, then I will be marking one arrow, and what is this vector? This vector is RA, and I can also write this one as what? RAO. ये वेक्टर लिखना सिखाया था ना लास्ट वीक में. Okay, we are moving from point A to point O to point A. So that vector will be written as RAO. Okay. Similarly, RBA means we are moving from point A to point B. So this one is RBA. Similarly, in between B and C, what we have? RCB. Here we have RDC. Okay. And if you are coming from D to A, what will be this one? RAD. Okay. So in between the joints, the vectors are known to you. Okay, so RA is written. Now let me come to RB, the position vector of B. Okay, what will be this one? The position vector of RB. If you see, it will be RA. We are talking in terms of origin. Why I have written this one? I have taken this additional because it is independent of origin. Whatever global coordinate, local coordinate you select, it's independent of that origin. Later on, what we will observe, that this RA is eliminated because RA is from origin to node A, joint A. So that will be eliminated. Okay. Overall, you will be getting only the loop, whatever loop you have formed. This loop may be of 4 members. This loop may be of 6 members. Okay. That is another thing. So RA plus RBA. Okay. That's fine. Then the next one is what? The position vector of C. B to aa gaya na aapka. So we will go for position vector of C. RC. RC will be equal to what? The position vector of B plus RCB. So I will write position vector of B plus RCB. Is it visible? Last bench. Okay. RB plus RCB. Now you see, what is RB we have taken? RB is RA plus RBA. So just I will replace that one. RA plus RBA plus RCB. Okay. Next one is what? I will go to joint D. Joint D is what? The position vector that will be equal to RC plus RDC. Are you getting what I am doing? We have a loop. That loop you have to identify definitely. Okay. Once you have got the loop, you have to follow, you have to start any one joint, whatever you are interested. Okay. It's not binding that you take this joint or that joint. It is independent. You have to select one joint as origin for yourself. And then you make the loop. That's it. Okay. You can select the joint B as your origin also. No issue. Okay. So RC plus RDC. And now RC I have written as how? RA plus RBA plus RCB and plus RDC. Okay. Still, our loop is not complete because we started from point A. So we are supposed to come to point A. So point A I will write RA. RA is equal to how much? Position vector of D, that is RD, and plus RAD. And RD is what? I will write the previous one. RA plus RBA plus RCB plus RDC. And last term is what? RAD. Now we started from joint A and we are back to joint A. So our loop closure equation is the final one, that is complete now. So now if you see on the left hand side, you have got RA, and on the right hand side also you have got RA. So they will basically cancel each other. So what we are getting? We are getting basically these 4 terms, isn't it? And that is equal to how much? 0. So now I will write RBA plus RCB plus RDC plus RAD equal to 0. This is our loop closure equation. Loop closure equation. Okay. Simply, if you see the position vectors we have used in the loop. Okay, nothing different. Now we can write it in different manners. I told you. Okay. Just I will do one thing. RAD and RDC. Okay. I will write in different manner. RBA plus RCB is equal to minus RDC minus RAD. Just I have transferred to the right hand side these two position vectors. And since they are vectors, if it is coming negative, simply you change the direction. It will become positive. Okay. So I will do that thing. So RBA plus RCD is equal to what? I have written something wrong. Yes.
Sir, RCB.
RCB है ना ये? Thank you. Okay. RBA plus RCB. So this will become what? RCD. मैं पहले ये वाला टर्म लिख देता हूँ, ठीक है ना? First I will write actually this term. RDA plus RCD. This is another loop closure equation. Okay. RBA plus RCB. Let me show you here. RBA is which one? This arrow plus RCB is this one. So basically, if you see the left hand side, we are coming to joint C. Okay, from one path. Now we will choose another path. And from there also we will go to joint C. So both the values are supposed to be equal. Okay. So the second path which I am choosing is which one? RDA plus CD. Means we are going from A to D and D to C. So A to D is where? This one. And C to D is where? This one. So we came to joint C in two different manners. So the left side, I mean the first value and the second value is supposed to be same. Because this is the resultant value, na? Shortest path. So they are supposed to be equal. So this is our loop closure equation. You can write, I mean, different way. RBA plus RCB plus RDC is equal to how much? RDA. वो भी हो सकता है ना? Okay. Simply you transfer only one term. Only RAD to the right hand side. So what will be the value? RBA plus RCB plus RDC is equal to, this will be minus and then RDA. This is also true. Okay. You started from point A, B, C and D. You came to D from one path and another path is directly to D. So they are supposed to be equal. Okay. So this is the loop closure equation for this particular mechanism. Now if you want to talk about the velocity, simply you have to differentiate this equation. Okay, with respect to something. Okay, and what is that? That is actually theta. Just I will introduce you because that is complex algebra. Okay, we are not going to follow any kind of mathematical treatment. I mean proper mathematical, because mostly they will develop the nonlinear equations. But still, if you are interested in dealing with that complex algebra approach, then you know that in complex one, this is I and this is J. I mean, sorry, I will write real and imaginary. ये तो आपने किया होगा ना? And if some point is given to you R, A, and this angle is theta. So you can write down its position vector. RA is equal to what? Mod of R iota theta. यही तो होता है ना? So for each and every one, for RBA, if you have this angle with respect to horizontal, so you can write RBA in terms of what? Position vector. Sorry, this complex number. Similarly, for everyone, the directions will be known to you. So you can write down in terms of RA and e power theta. And once this is written, you segregate the complex and the the real part and imaginary part. ये तो करते हैं ना, real को एक साथ कर लीजिए, imaginary को एक साथ. And then there are different ways. You divide them. So what you will get? Theta. Normally ये होता है ना, left hand side में एक value रखते हैं केवल, only one angle. Okay, like theta 2, theta. So you will get the theta angle, and then you find out the magnitude. I mean, that is one way. वो मैं डिटेल में तो नहीं कर रहा हूं, but definitely this is the approach, one approach, the complex algebra approach. Okay, so if you are putting this value here, what you will get? RBA is equal to, basically, like you can write down, if this angle is theta 1, let me say this angle is theta 1. So RBA you can write down as its magnitude and e to the power j theta 1. ठीक है ना? अब इसको डिफरेंशिएट करेंगे तो यहां से आपको एंगुलर वेलोसिटी मिल जाएगी, यू विल गेट द ट्रांसलेशनल वेलोसिटी, एवरीथिंग. ओके, वेलोसिटी में हम इसको थोड़ा सा आपको दिखाएंगे, हाउ वी आर गेटिंग द वेलोसिटी टर्म्स फ्रॉम हियर. Okay, but for position analysis that is not required, because this is proper pure mathematical treatment. So now I hope that you understood how to write the loop closure equation. Another thing, the vector notation, whatever I have followed, you can choose your own. It doesn't make a difference whether you are writing it RBA or you are writing RB. It's not, I mean, matter of concern at all. What you have to do, you have to follow the loop. Whatever you are writing, that you show properly. ठीक है ना? R1, if you are writing R1, R2, R3, R4, 4 बार मैकेनिज्म है अगर आप पे, you are writing R1 plus R2 plus R3 plus R4. Okay, no issue. You show it that this one is R1, this one is R2, this one is R3. Okay, so please do not be concerned about the notations. You may forget, but you know that what is the loop. That is something you are supposed to know. I will show you one. Just you tell me the loops. What are the loops we are forming? And then ये 4 बार mechanism हो गया ना. So do I need to draw the 4 बार again? I mean, it's proper 4 बार. ठीक है, तो कोई भी 4 बार linkage होगा, it will be the same thing. There are 4 vectors. You have to add them together. If you are moving in a circular form. और अगर दो साइड से मूव करेंगे, then left side and right side must be equal. Okay. So I will. Okay, I will show you the slider crank first of all. वो सिंपल है और थोड़ा सा उसको टिपिकल दिखाऊंगा, because you have different ways to write down. This is offset actually. This, if you see, the slider is not on the line of link 1. Okay, earlier I used to show something like this one, na? That slider will be along the shaft. Shaft means at point A. Okay, so I have shown its offset, no matter, no issue. Okay, AB, this point is C, and we have got the slider as D. Okay, so simply I will write here, actually you can write anything. I will write this one as R1, this one is R2, no issue. Okay, the vectors are known to you, this one and this one. Okay, and then you can mark the closing vector also. So marking the closing vector, you have 2 ways. The one is that directly you join point A and point D. Okay, and I will write this one as, let me say R. I mean the resultant kind of thing. So that is one way. Okay, another way is what? That if you are not interested in this one, then you know that we can draw a horizontal line and then a vertical line. The horizontal line, this arrow, and vertical line, this arrow. And you know that this R is what? The resultant of, I will write, let me say this one is R3 and this one is R4. So R is what? The resultant of R3 and R4, isn't it? So you can move horizontal then vertical to reach any point. That will create a loop without any issue. The one is what? That you move from joint to joint to create the loop. Another one is that for any joint you can move horizontal and then vertical. The thing is you are not supposed to break that loop. वो कहीं पर आपका हटना नहीं चाहिए. Okay, so this is one way. So one loop actually will be which one? R1 R2 equal to R3 plus R4. यही तो होगा ना. देखिए हम यहां से राइट से मूव कर रहे हैं, ये एंड ये. दिस इज फर्स्ट लूप एंड द सेकेंड लूप इज दिस वन एंड दिस वन. So R1 plus R2 is equal to R3 plus R4. Arrow mark कर दीजिएगा because I am not using the proper notations. I told you that please do not be concerned about the notations. Simply mark the arrows. Okay? मैंने arrow सारे mark किए हुए हैं. Everything is visible to you. So R1 plus R2 is equal to R3 plus R4. Okay? And you know that R3 plus R4 is what? R. And that is another way to write that one loop is R1, R2, another is R. So you can write down R1 plus R2 is equal to R. Okay, you can have actually the multiple loops also. That is one good example, and I have drawn here. Just I will Watt's mechanism, one of the isomers actually for Watt's mechanism. Okay, so just I will show you. This is a ternary link, okay? That is why I have. So these are the grounds, 2, 3, this one is link number 4, 5 and 6. Okay, now you remember that these joints, they will definitely form the loop. Okay, so please do not keep them outside the loop. जो joints हम member छोड़ देते हैं ना, because they are, I mean, in between the fixed grounded joints. So we used to remove that member, but they will be part of our loop calculation. Okay, so this one will be the loop. अब ये बताइए इसमें कितने loop बनेंगे? How many loops? Which one is the third one? दो तो हमको दिख रहे हैं. The one is left hand side, another is right hand side. And I have said it that link, ternary link, quaternary link, etc. It's the boundaries of that link. They will not create any loop. That is a single link, na? So the boundaries of that single link will not create any sort of loop. तो आपका दो लूप बनेगा. एक क्या बनेगा मैं आपको एरो दिखा देता हूं. You start from this point, this one, और दूसरा लूप आपका कहां बनेगा? You can write down the loop closure equation without any issue. ठीक है ना? Dimensions are known to you. So these are the two loops we will be getting. So actually looking for the loops is of course the tough task. ये simple mechanism है, but of course if I am giving something where you have actually got the higher pairs also. इसमें क्या है? सारे lower pairs थे ना? Only the revolute joints. But if you are getting a combination of higher and lower pairs, then again it will be little bit of tough. Okay. वो हम लोग next class में of course will be dealing with how to identify the loops. We will take up some example as well. Okay. So this was all about the loop closure equation. This will be useful in our velocity and acceleration analysis, along with the vector notations, whatever we have followed. So basically the next class we will be dealing with the velocity analysis. Position analysis, the fact is data will be given to you that you have got a 4-bar mechanism. These are the links 1, 2, 3, 4. The length etc. is known to you. One angle will be known to you. So graphically actually you can draw. एक थीटा मिल जाएगा तो आप ड्रॉ कर सकते हो ना. I have shown you in the class also that if all the links are known to you and one angle is known to you, so you can easily draw the 4-bar mechanism. Okay. So basically once you have drawn, then we'll be writing the loop closure equation and we'll go for the velocity analysis. ठीक है ना? So next class we'll be taking up that case. For today this will be enough. ऑनलाइन वाले तो क्लास कर नहीं रहे हैं.